Hey dude, thanks for visiting. In this lecture, we are going to discuss the calculus of variation questions paper from the questions of on the exam paper of CSIR NET 2022 February section. Okay, in this year in the questions paper, just a second. In the questions paper, total 3 questions comes in the exam. Okay, and of these 3 questions, 1 questions is of 3 marks and 2 questions are of 4.75 marks. Okay, so there are never doubt 13 marks you can say comes in the paper from the calculus of variation part. Okay, so you can see that weightage of the calculus of variation topic is very good in the CSIR NET exam. Okay, and one more thing I must say that these 2 questions of 4.75 marks which comes in this paper are very conceptual question and very good type of questions. Okay, so you must watch the complete solution to understand the solutions, and I must say that after watching this video you get a clarity on the paper or on the questions, how can you solve the questions. Okay, and one more thing is that you can also watch the calculus of variations lecture in the channel of the learning field, that is in my channel. You can also get the lecture series of calculus of variation. I'll share the link of the playlist in the description box and also in the iTab. You can also watch the calculus of variation lectures, and you can say and you will must get clarity on the subject of calculus of variation, I must say. Okay, so let's start with the question. This is the first question and this is a questions of 3 marks. Okay, and one more thing is that if you like the content, then obviously subscribe the channel. If these lectures helps you a little bit in your preparation, then obviously subscribe the channel. Okay, and share with your friends as much as you can. Okay, so let's start. So and one more thing what is that? That is I will share this solution of these questions, 3 questions in my Telegram channel. So you can see, or after watching this lecture you can also visit my Telegram channel to get this PDF, okay, of the lectures. So because the questions are big questions of 4.75 marks questions, okay, so you can watch the solutions. Okay, so it says that which of the following is an extremal of the functional jy is equal to -1 to 1 y dash square minus 2xy dx that satisfies the boundary condition y minus 1 equal to 1 and y equal to 1. Here 4 options are given. Okay, so we first see whether these 4 extremal satisfies the boundary condition or not. In the 4th option, from these 4 options, which extremal does not satisfy the boundary condition, we can discard that option. Okay, so and okay, let's try from the beginning, that is from the method. Okay, so you can also check by putting these conditions to the options whether these 4 options satisfied or not, then you can discard from that. Okay, so here given f equal to what, y dash square minus 2xy. Okay, now the Euler-Lagrange equation is what? Euler-Lagrange equation del f del y minus ddx of del f del y dash is equal to 0. Okay, so del f del y means what? Del f del y means minus 2x minus ddx of what? Del f del y dash means 2y dash is equal to 0. This implies what? X minus y double dash, this is equal to 0, and this gives y double dash equal to minus of x. Okay, now if we integrate, so you can simply find y dash equal to minus x square by 2 plus a, and this implies y equal to minus x cube by 6 plus ax plus what? b. Therefore here the highest degree of the polynomial is x cube. Therefore we can easily discard this option and this option by after watching this after watching the value of that is the extremal. Okay, now if we apply the boundary condition, that is y minus 1 equal to minus 1 gives what? Y minus 1 equal to minus 1 gives minus 1 equal to minus of minus 1 by 6 minus a plus b, which gives minus 1 by 6 is equal to b minus a. Okay, so that means we get from here b minus a equal to minus of 7 by 6. B minus a equal to minus 7 by 6. and so this implies we can write a minus b equal to simply 7 by 6. Okay, now y1 equal to 1, this gives what? 1 equal to, what is the extremal? Minus 1 by 6 plus a, minus 1 by 6 plus a plus b. So this gives a plus b, this is equal to 1 plus 1 by 6 is equal to 7 by 6. Now if we simply adding this equation 1 and 2, then we must get 2a equal to 7 by 6 plus 7 by 6, which is equal to a equal to simply 7 by 6. Okay, so a equal to 7 by 6, and if we put in any of these two equations, then we must get b equal to 0. Therefore the extremal is, this is equal to minus x cube, yeah, minus x cube by 6, minus x cube by 6, and a means plus 7 by 6 plus 7 by 6 into x, yeah, and b value is 0. So this is the required extremal, that is which option? Sorry, option C is the correct option. Okay, now going to the next question. This is a question of 4.75 marks. Okay, so the question says that at x equal to y such that y belongs to C1 0 pi. This C1 0 pi means differentiable smooth function, you can say, or this, and this can also be noted as the differentiable function up to order 1, that is first order differentiable. Okay, so y0 equal to 0 and y pi equal to 0, and define j equal to x to r by jy equal to integration 0 to pi y square minus 1 minus y dash square dx. Then which of the following options are true? Okay, here options are given. So y is identically 0, is a local maximum for j with respect to C1 norm. So here we also introduce the norm here, C1 norm and the supremum norm. Now we define the supremum norm, what is supremum norm and what is the C1 norm. Okay, so first we calculate the extremal. Okay, so f equal to given y square into 1 minus y dash square. Therefore simple Euler-Lagrange equation is del f del y minus ddx of del f del y dash, this is equal to 0, and simply we can calculate this one. So ddx of y square y dash is equal to y into y 1 minus y dash square. So this is simple calculation, you can simply see this and see up to after the last one. So we get here after the last line we get y square by 2 equal to minus x square by 2 plus cx plus c2, or you can say this is c1 or c2. Okay, so I must say that I share this PDF in my Telegram channel. You can watch this PDF or you can see this PDF. Okay, because you need this PDF, I think. So applying boundary condition y0 equal to 0, this implies c2 equal to 0, and this gives y square equal to a minus x square by 2 plus cx. C is the first integrating constant, and y pi equal to 0. These two are given boundary conditions, gives this is, and this one is the given boundary condition. Okay, so these two gives c equal to pi by 2. Therefore the equal extremal is y square equal to this one minus x square by 2 plus pi x by 2. Therefore we get y equal to root under x into, I think you can see this, y equal to x into what, pi minus x, since x belongs to what, 0 pi, therefore we take simply positive root, square root. Okay, now we define the norm, that is the C1 norm and the supremum norm. So this is the C1 norm. C1 norm is defined by, that is norm of 1. This is equal to, simply just define the norm in the vector space also, you can say, or in other topics you can also define the norm. This is similar norm. Okay, so we generally define this C1 norm, this is equal to root under y transpose dot y, and here since this is not a vector, this is case of vector, so here just we multiply the 2y inside the root, square root. Okay, so this gives x square into pi minus x whole square, and supremum norm, that is norm infinity, this is equal to supremum of x belongs to 0 pi yx, this is equal to supremum of what, 0 pi by 2 and 0, this is equal to pi by 2. How we get this pi by 2? देखो यहाँ पर क्या है, So to get this pi by 2, how can we find this pi by 2? See, here we first calculate the, or we calculate the, or we extremize this, sorry, here we find the point in which the y curve, that is this extremal, gives the extremum value, that is either maximum value or minimum value. Therefore, how can we simply apply the f dash, first we apply the y dash, then we calculate y dash x equal to 0 and find the point, and we check on that point. Okay, so y dash yx equal to this one, y dash x equal to this, and y dash equal to 0 gives x equal to pi by 2. So this is the point of extremum. So this is the point I put here. Okay, so supremum of 0, pi by 2 and 0, that means here what is this? This is the value x equal to pi by 2. Sorry, one more mistake I made here. So which is equal to, now it is given y0 equal to 0 equal to y pi, and pi by 2 is also a point of extrema. Therefore y pi by 2 equal to, we just calculate here. Here we calculate y pi by 2 equal to, just you put in the norm, or you can also put here yx equal to here. So y at pi by 2, this is gives you again pi by 2. Therefore we calculate the supremum here. This is the value of y0, this is the value of y pi by 2, and this is the value at y pi. Okay, so this is the supremum which is equal to pi by 2. Now we go to the options. Okay, so for supremum norm, we first read this option C and D, which contains the supremum norm. Okay, so C, option C says that y is identically 0 is a local minimum for j with respect to the supremum norm x, and y is identically 0 is a local minimum with for j with respect to the supremum norm x. But here the supremum norm of y we get, which is equal to pi by 2 here, which is not identically 0. Therefore we discard these two options, because y, supremum of y equal to, we get pi by 2, y is not identically 0 in that case. Okay, so we can discard option C and option D from here. Okay, I think you all are understand this or you all can understand these norms. Okay, now we go to the C1 norm case. Okay, now here we can simply discard option C and option D, but whether for option A and option D, we must know one thing, which is the local maxima and local minima, the definitions of local minima and local maximum. Okay, so what is the definitions, or you can just go through once. So it says that a function f from I to R is said to have local maximum at a point C belongs to I if there exists a neighborhood n C delta of C such that fc is greater or equal to fx for all x belongs to n C delta intersection I. So this is the definition of local maxima at a point C. Okay, now what is the definition of local minima? So a function f from I to R is said to have local minimum at a point C belongs to I if there exists a neighborhood n C delta of C such that fc is less equal to fx. So in that case fc is greater or equal to C fx, and fc is less equal to fx for all x belongs to n C delta intersection I. Okay, now we come back here. So see here y0 equal to 0, y pi equal to 0, these two are the boundary conditions which are given in the question, and y pi by 2 equal to pi by 2, which we are calculate. Okay, which we calculate. Okay, now y0 we must say y0 is less equal to y pi by 2, because y0 gives 0 and y pi by 2 gives pi by 2, and y pi, this is again less equal to y pi by 2, because y pi by 2 against 0. So this is 0 less equal to pi by 2 you can say, and this is 0 less equal to pi by 2 you can say. Okay, I think you will see these two inequalities. Okay, therefore now by the definition of this local maximum and local minimum, we can say that x equal to 0 and x equal to pi, these 2 points, in these 2 points we get local minimum. Okay, because y0 is less equal to y pi by 2 and y pi is less equal to y pi by 2. So see this definition, this is the definition for minimum. y0, that is at C equal to 0 or pi, we get less equal to fx, where x belongs to n C delta intersection I. So pi by 2 can belongs to neighborhood of this point which is जो 0 का एक neighborhood लो, वहाँ पे 0 plus something and 0 minus something and 0 plus something intersection 0 pi. So 0 minus suppose delta and 0 plus delta intersection I क्या है, I है 0 pi. Okay, so pi obviously belong कर रहे हैं in this interval if we choose such a delta. Okay, for any point यहाँ पर बोला है, ठीक है. तो for any point we can find an interval this such that pi belongs to this one, or again you can say 0 belongs to this one. Okay, so that means these 2 points 0 or pi is the point of minima. We can definitely say clearly from the definition of the local minimum. Okay, you can choose the such delta, that's why based on this delta you can obviously get this 0 and pi in this interval. Okay, now therefore what is the case, 0 and pi are the point of local minima. Okay, similarly we can say that, so 0 and pi are the local minima. Okay, from the definition. Similarly, if we see the converse inequality, that is fc is greater or equal to fx, that is we can say for the point pi by 2, we say that this pi by 2, since y pi by 2 is greater or equal to y0, okay, therefore for this point choosing C, we can say that this pi by 2 is a point of local maxima. Okay, so minima point is pi by 2 and 0 and pi, and maxima point is pi by 2. Okay, and if we calculate the norm, that is this C1 norm, the norm at the point 0, which is equal to what, if we put here the 0, then we will get simply 0, and if we put norm at y pi, then we will get what, if we put here the pi, then we can also get 0. Okay, so y is identically 0. Okay, for the for these points. Okay, now if we put y at pi by 2 here and taking the norm, then we get pi by 2. Oh, so just I write here we write, so pi norm of y at 1, this is equal to root under of x square into pi minus x whole square. So norm at point pi by 2, this is equal to, so pi square by 4, and we get pi minus pi by 2 means pi by 2, which is equal to pi square by 4. Pi by 2, yeah, pi square by 4. So this is equal to pi square by 4. Yes, pi square by 4, which is not identically 0. Okay, so this is not identically 0, but these 2 points at 0 and at pi, these 2 points gives minimum, as well as these 2 points satisfying the given criteria. Okay, that is y is identically 0. That is the option A says that y is identically 0 is a local minimum for j with respect to C1 norm on. Yes, this is the correct option, this is correct option. And it says that y equal to y is identically 0 is a local minimum for j with respect to C1 norm. No, this is not identically 0. Okay, y is not identically 0. This gives only minimum. Okay, the maximum case is the point for the point pi by 2. Okay, so this is the correct option, option A here. I think you all understand this problem. I'm tried my best to understand this problem, okay, to you. So you can definitely comment that you will either understand or not. Okay, so this is the second problem, and this problem is of 4.75 marks. Now going to the vital problem. This is the third problem and the end problem, okay, of today's class. So it says that let B be a unit ball in R3 centered at origin. The Euler-Lagrange equation corresponding to the functional IU equal to integration over B 1 plus grad U mod grad U whole square power 1 by 2 dx. This is equal to, these 4 options are given. So see, this is just not a simple or you can say normal type or simple type calculus of variation problem. Here del or nabla operator is included in this problem. Okay, so here you can also say that here the space is R3. That means we get the, that means what, del of u. How can we define this del of u in the vector space? Okay, or in 3 dimension we can use grad u or nabla u, this is equal to I del x plus j cap del y plus k cap del z on this function u. That is del u means I del x plus j I cap del u del y plus k cap del u del z. That means we can write this as ux iota cap plus uy j cap plus uz k cap. Okay, so this is the nabla or del operator, okay, in the vector. Now if we write the Euler-Lagrange equation, so see the solutions of these questions. See, f equal to given here 1 plus mod grad u whole square power half. So mod grad u is equal to what? First we calculate here the grad u. I just see you that this is the gradient ux iota cap plus uy j cap plus uz k cap, because here the space that is b we take here is R3, therefore 3 coordinate comes in this case of this problem. Okay, now mod grad u equal to, we simply write root under of ux square plus uy square plus uz square. Now this is the simple Euler-Lagrange equation. I just write it here to understand the difference between these two Euler's equations. Okay, but in case of space we write it as the extension of this Euler-Lagrange equation, and we say the equation by name Euler-Ostrogadsky equation, which is del u del x minus del x of del f del ux plus del y of del f del uy del z of del f del uz. See here the differences. This is for only case of one space, or this is for real number, this is for the space R. When the space comes to, or the dimension of this space increases, then there the terms also increases, and here only one single variable, that is y is only, here y is only the dependent variable and x is the only independent variable here. But here you can see that this is like the partial derivatives. Okay, so here only ddx term comes, therefore in this case there are three डेरिवेटिव का टर्म्स, थ्री अलग अलग टर्म्स होगा. तो ये क्या होगा, डेल डेल एक्स ऑफ डेल एफ डेल यू एक्स, एंड हियर वी आल्सो राइट y dash here, therefore this means the space u here is the function of u x y and z. Okay, and p and q, that is ux uy uz also. So f is the function of x y y dash था, यहाँ पे क्या होगा, x y z and ux uy and uz. Okay, that is del u del x del u del y del u del z. So this is the Euler-Ostrogadsky equation. In this equation we say, and we can write in terms of, or in the form of del f del u minus gradient of, or you can say this is the not gradient, this is the divergence of del f del grad u. Okay, this is the vector notation. See here we write here, this is 1, this is the gradient, and del dot u means this is the this is gradient in vector, and this is divergence in vector. We write this div of u. Okay, this is the divergence. Divergence means what? I just write here del dot any function, for any function suppose g, this is equal to I del del x plus j del del y plus k del del z dot, if this g is a vector function, this is equal to, you can write suppose g1 I cap plus g2 j cap plus g3. I think you all write, or you all see this just you I write in the left side. Okay, so if g equal to is a vector quantity, g1 I cap plus g2 j cap plus g3 k cap, then what is the del dot g? Del dot g, this is equal to, this is dot product, so I dot I equal to, we know that I dot iota is equal to 1, j cap dot j cap, this is equal to 1, and k cap dot k cap is equal to 1. Therefore these three quantities are only present, so we write this as del g1 del x plus del g2 del x del y plus del g3 del z. So divergence means this one, and gradient means, so divergence and gradient means I just this one. So gradient is a vector quantity, but divergence not a vector quantity, it's a simply scalar quantity because I, j and k are not present here. Okay, so this is the case. So we write here this one as del f del u minus gradient of, or you can also write this as del f fu minus divergence of del f, okay, and del grad u, okay, this like this. Okay, so f is equal to this one, and now grad u mod grad u whole square means this term 1 plus ux square plus uy square plus uz square power half. So you must see the solution of this problem twice if you don't understand, because this included the vector terms or vector quantities. Okay, so now here f is equal to this one. If we break the term, because f is equal to kya tha 1 plus mod grad u whole square power a half. Now we break it, so we get this term. Now the Euler-Ostrogradski equation is this one. Now we calculate these three terms, del f del ux, del f del uy and del f del uz. Now del f del ux, this is equal to half into, this is the f, so half into this term and ddx of del x del ux of this one. So this gives this term, so this gives simply ux into 1 plus ux square plus uy square plus uz square power minus half. This is simple derivative formula. Similarly, we can write del f del uy equal to uy into 1 plus ux square plus u square plus uz square power minus half. Del f del uz is equal to uz into 1 plus ux square plus uy square plus uz square power minus half. Okay, now from the equation, this one del f del u term goes to 0, therefore माइनस कॉमन लेके इधर में चला जाएगा तो 0 हो जाएगा वो भी, ठीक है. तो सिंपली क्या बचा, इन तीनों टर्म का सम, ठीक है. नाउ वी राइट this three terms, so del x of, this is the del f del ux plus del y of this y uy by this term 1 plus ux square plus uy square plus uz square, and del z of uz by 1 plus what, this ux square plus u square plus uz square power half. Okay, so see how can we write दिस टर्म. सो माइनस कॉमन लेके ये तो इधर चला गया, काट हो गया, ठीक है. तो देख डाइवर्जेंस का फॉर्मूला क्या था, देखो यहाँ इसको हम लोग क्या लिखेंगे, डाइवर्जेंस ऑफ ग्रेड यू और डेल यू बाय दिस इज द डिनोमिनेटर टर्म. व्हाट इज दिस डिनोमिनेटर टर्म मींस सिंपली दिस वन. सो दिस इज ए स्केलर क्वांटिटी. ओके, दिस इज ए स्केलर क्वांटिटी simply, and this no, this is the quantity, just a second. So this is the quantity, numerator quantity, and we can write these three term as this divergence form. So see, I just understand you to this thing. So divergence of this one is equal to, we get del g1 del dot g means del x of g1, and g1 means what, g1 means completely this term here, del x of this term. So this term is, if we take this g1, then we write this is the divergence, okay, of grad u by this one. Okay, so I think this will be clear. You must once write this in your exercise book. Okay, so now, so divergence of this means 0, it is given. So if we see the options, okay, so options, this is options A only given, so options A clearly true. Okay, now go to the next question or next part. It will say that B, see here one term is again forward delta is given. So I don't know whether they gives the wrong one or they mistakes the this is the mistake of printing, because जो है forward del, that means downside upward जो delta है ये यहाँ पर वेक्टर में कोई काम का नहीं है, बट they can use this as a Laplacian operator, which is equal to, you will also say that del square f, this del square is called the Laplacian operator. Del square equal to del 2 del x2 plus del 2 del y2 plus del 2 del z2. This is the operator which is called the Laplacian operator. Okay, and which is equal to del dot del f, that is divergence of gradient f. This is denoted by del square f. Okay, so this is the vector terms, all are vector terms. Okay, so now if we proceed further these questions, then given that B is a unit ball in R3 centered at origin, that means the equations of this unit ball is, we can also write that x square plus y square plus z square minus 1. Okay, this is the equation of sphere, you can say, in the 3 dimension. Okay, now if we take the gradient, because u is the function of what? U is the extremal curve, and extremal curve on what? On the unit ball in the R3. So we take here simply gradient. So gradient equal to, this is the function, if the function is known, u function is known. Okay, so if we take this one, then we can definitely calculate del del x of plus del del y of this one term. So this gives simply from here we get 2x iota cap 2y j cap plus 2z k cap, and mod grad u equal to 4 x square plus 4y square plus 4z square from this, which is equal to simply 2. Okay, so mod grad u का जो वैल्यू है वो क्या है? 2 है. In the option C it is given mod grad u is equal to 1, therefore this is not correct option. Okay, now if we take this forward del as a Laplacian operator, then what happens we see? Or they mistake with the backward del operator or nabla operator, then other cases happen. Okay, so here I choose, suppose it is, that can be mean by this delta means this grad square f. Okay, then what happen? So if this happen, because if we take this one, then the answer for the case of the option D, here also one this forward del u given. If we take this, then the answer will be matched. Okay, so we start take this one, then grad square u, this is equal, nabla square u, which is equal to, this is del dot del u. Okay, so del dot means I del del x plus j del del y plus k del del z dot, this is dot means vector dot product. Okay, vector dot product of 2x iota cap plus 2y j cap plus 2z k cap, which is the grad u value, which is we calculate here. And if we calculate, then we get I dot I means 1, therefore del del x of, this gives, this means actually what? Del del x of 2x I dot equal to 1 since, plus del del y of 2y plus del del z of 2z, which gives 2 plus 2 plus 2, which is equal to 6. I think you all see this. Okay, therefore this divergence of grad u value is 6, and if we put the value 6 here, then this value deep grad u we mean this grad u by the Laplacian grad square u, then this gives 6. Okay, and this is fixed, therefore this cannot be 1. Okay, this cannot be 1. Okay, I think that they mistake here. If we take this upside down triangle, that is the nabla operator or the del operator, this says as del operator or nabla operator, this is del or nabla. In vector calculus you must see, but in vector calculus this type of notation I cannot see, or I know I am not see, or I not this type of notation वेक्टर में तो मैं कभी भी नहीं देगा. ठीक है, तो ये जो केस है मतलब ये बनेगा यहाँ. ठीक है, तो सपोज लेट अस टेक डेल डॉट यू इज इक्वल टू यू एक्स एक्स प्लस यू वाई वाई plus u z z. This is Laplacian. If we take this, then the fourth option is true, and fourth option exactly matched. And in the questions paper also answer is given option A and D. Okay, so this is not correct if we take the this del. Okay, so you can also comment me if I made any mistake in the question here. Okay, I just explain the question, try to explain the question. Okay, now we calculate, this is the equation, so we derivative these terms, del x of this one, del x of del y of this term, and del y z of these terms, these three terms. Now we derivative with respect to del x, del y and del z. So now del x of ux into 1 plus ux square plus uy square plus uz square power minus half, this gives uxx, first we derivative this term and this is rest, and then ux derivative of this term gives minus half to the power minus 3 by 2, and del x of this one, this gives 2 ux into uxx plus 2 uy into uyxy and 2 uz into uxz. And here already we also use this one, uxy is equal to uyx and uyz equal to uzy and uxy uyz is equal to uzy. These three here we take easily, or we assume that this holds. Okay, so now we get this term into 2 into this term, and if we write uxx by 1 plus ux square plus uy square plus uz square power half into ux into this term by this power 3 by 2. So we write just here uxx into, because this is half power and this is 3 by 2 pair, therefore here 1 power with this bracket multiplied by with uxx. Okay, so uxx into 1 plus ux square plus uy square plus uz square minus ux into this term rest by 1 plus ux square plus uy square plus uz square power 3 by 2. I think you all see this line. Suppose this is a. Okay, similarly y का रेस्पेक्ट में डेरिवेटिव का तो क्या आएगा, uy into this term माइनस uy into, देखो क्या होगा यहाँ पे सिमिलर टर्म होगा यहाँ पे, ठीक है। तो देखो डेल वाई के साथ क्या होगा, uy into this term एंड uy into ux uy, तो इसके मतलब डेल वाई के रेस्पेक्ट में डेरिवेटिव करेगा तो क्या होगा, डेल वाई ऑफ 1 प्लस ux स्क्वायर प्लस uy स्क्वायर प्लस uz स्क्वायर क्या होगा, देखो 2ux into uy होगा, सॉरी 2 तो हो जाएगा, मतलब क्या होगा, ये टर्म फर्स्ट आएगा 2 into ux प्लस uy प्लस uz into डेल y ऑफ ux प्लस uy प्लस uz, ये टर्म आएगा, ठीक है। तो ये ऐसे कैलकुलेट हो रहा है यहाँ पे, नो सॉरी आई मेड ए मिस्टेक, ux स्क्वायर, sorry, if we see the first one, then this, then 2ux into uxx, yeah right, ठीक। तो देखो ये टर्म आएगा ux into uyx plus uyy plus uz into uyz by this square, this term is common in the 3 terms, see, then del z of uzz into this term fixed minus uz into this term fixed, मतलब यहाँ पर क्या चेंज हो रहा है, ux into uzx, मतलब z के रेस्पेक्ट में हो रहा है, ठीक है। देखो ux uy uz तो था, तो यहाँ पे क्या हो रहा है, ux into uzx uy into uzy, z का रेस्पेक्ट में यहाँ पर एक एक्स्ट्रा डेरिवेटिव हो रहा है, ठीक है, and uz into uzz by this term. Now we put these 3 values a, b and c in the equation this. So we calculate this whole term, this whole term, then this whole term, and then now we put these 3 values in the equation 2. Then we get what? We get, देखो यहाँ पे जो नीचे ये था, तीनों के तीनों में भी था ये, तो ये कैंसिल आउट कर रहे हो, मतलब यहाँ पे तो और कुछ टर्म नहीं है, राइट साइड में 0 है, तो ये राइट साइड में जाकर 0 कर रहे हैं हम, ठीक है। तो ये टर्म में यहाँ पे और नहीं लिखा, तो देखो क्या मतलब यहाँ पर नेक्स्ट क्या आ रहा है, देखो तो uxx into 1 plus ux square plus uy square plus uz square minus ux into this one, this is the case comes from a, this line comes from B and this line comes from C, the derivative terms. Okay, now if we add, then this goes common. So 1 plus ux square plus uy square plus uz square plus uxx plus uyy plus uzz, this three, this term, this term and this term. And then here we get the remaining terms, and here we get 9 terms exactly. देखो यहाँ से 3 terms, यहाँ से 3 terms, यहाँ से 3 terms, and if we write these 9 terms in the right side, then we write this is the left side term and these 9 terms are right side. Here 9 terms are present. देखो uxx 2 3 terms, 4 5 6 7 and 8 9. Okay, so these 9 terms are present in the right side. Now this can be written as 1 plus grad square. Therefore these terms comes, if we write these terms by delta u as a product, okay, because this is not the dot product, this is simple product, so simple product del u, then this answer is exactly match. How this match exactly? देखो यहाँ पे क्या है uxi, मतलब यहाँ पे हम लोग x y z लेके चल रहे हैं, एंड ये लोग जो आंसर यहाँ पे दिया है क्या है x1 x2 x3. ओके, तो यहाँ पर 9 टर्म्स आएगा. ठीक है, ठीक है. तो आई थिंक यू विल अंडरस्टैंड दिस because there are 9 terms, because I vary from 1 to j. For each I we will get 3j. For I equal to 1 we get 3 terms, j varies. For I equal to 2 we get 3 terms because j varies from 1 to 3, and for I equal to 3 again we get 3 terms for since j varies from 1 to 3. Okay, so here we get exactly 9 terms, and we get exactly 9 terms here. And if you say me that sir here 2 uy ux and uz comes, so देखो this type of terms कैसे आएगा? 2 terms देखो, एक आएगा ux uy uxy and one another term जो आएगा वो आएगा uy ux uyx. तो ux and uxy को हम लोग यहाँ पे सेम लेके चल रहे हैं, तो ये क्या आएगा, ये 2 टर्म मिलके एक 2 आ जाएगा सामने. ठीक है, ये यहाँ का केस है. ठीक है, तो ये एग्जैक्टली मैच कर रहा है, कोई दिक्कत नहीं है यहाँ पे. ठीक है, देखो आप लोग x1 x2 x3 लेके कर सकते हो इसको, मतलब वो करोगे तो थोड़ा नोटेशंस का दिक्कत रह जाएगा, इसलिए यहाँ पे x y z लेके करना सेफ है. ठीक है, प्रॉब्लम ये यहाँ का केस है. तो ये एग्जैक्टली आंसर से मैच कर रहा है. इफ वी टेक दिस uxx uyy and uzz, this delta u, that is this, if this represents the Laplacian of u, okay, then the answer match, and it is also given in the answer, right answer, and this is exactly same because I here calculate all the terms. Okay, so you can definitely say this answer D is correct. Okay, and uxx uyy uzz भी यहाँ पे हम लोग कैलकुलेट किया तो सेम लेके चले, क्योंकि यहाँ पर जो मतलब u डेल u का वैल्यू हम लोग क्या लेके चल रहे हैं, uxx प्लस uyy प्लस uzz, दैट इज द लैप्लासियन, एंड सेम लेके चले, तो यहाँ पर ये बी ऑप्शन गलत हो रहा है. एंड यहाँ पे बी आंसर में भी नहीं है, सिंपल आंसर में क्या क्या है, ए एंड डी गिवन है. ठीक है, तो देखो ये प्रॉब्लम का जो मतलब एक्सप्लेनेशन था, आई ट्राई टू गिव द एक्सप्लेनेशन ऑफ दिस क्वेश्चंस, एंड आई थिंक दिस इज द करेक्ट एक्सप्लेनेशन. ओके, so you just see this explanation and you can comment me if I made a mistake here. Okay, I think I am not made any mistake here. Okay, but हो जाता है कभी कभी, if हो जाता है तो आप लोग मेरे को कमेंट सेक्शन में जरूर बता सकते हो. ठीक है, तो ये था मतलब कैलकुलस ऑफ वेरिएशन का 2022 फेब का CSIR नेट का पेपर सॉल्यूशन. ठीक है, तो इफ दिस कंटेंट और इफ दिस लेक्चर हेल्प्स यू, देन ऑब्वियसली गिव ए लाइक टू दिस सेशन, एंड बिकॉज आई मतलब क्या है, इस लेक्चर को करने के लिए मेरे को बहुत हार्ड वर्क करना पड़ा है, क्योंकि ये जो प्रॉब्लम्स था, मतलब प्रॉब्लम्स जनरली कॉमन प्रॉब्लम्स नहीं था, मेनली जो 4.75 का 2 क्वेश्चंस था. ठीक है, तो ये था इसका सॉल्यूशंस. I'll try to give the solutions and I'll provide, I think these are the correct explanation. Okay, so helps you, then obviously like and obviously share as more as you can with your friends, and obviously जो लोग नए हो चैनल पे प्लीज सब्सक्राइब कर देना. ठीक है, तो चलो चलते नेक्स्ट वीडियो में देखा होगा. ठीक है, चलो बाय, मिलते हैं अगले वीडियो में.